In this video I'm just going to take you through using desmos to graph the results of a arithmetic sequence and series. So we've looked at using sliders before, but another way that we can put in multiple values of data is through this means. So you basically set up some beginning values in a pattern separated by commas, and you put in 3 dots and then your final value. So that's basically telling desmos that we've got a variable n that's going to have 10 discrete values from 1 to 10. Now for an arithmetic sequence, we know that a is something significant, so let's put in a variable for a and give it, say, a value of 1 to begin with. We know as well that d, the common difference, is significant, so let's put that in as well. And in the end, our value of each term is going to be based on the expression a plus n minus 1 times by d. What we can do is to graph a point for each value of n. We can have a matching value of tn, which effectively goes like this. So if we want to actually just graph a point rather than an equation, which is what we've done in the past, we need to say, well, what is the x value? So let's treat the x value as n, and let's treat our y value as being a plus n minus 1 and then times by d, and that actually gives us the graph that we're after. So I could move this across here if I wanted to. I'm only wanting to go to the value of 10 on the x, so I could change this to 10, make sure it goes up by 1, and that gives us the graph that we want. If we wanted to, we could also label each of those points so we could see what they were, and as we change our values of a and change the values of d, we can see the representation of that sequence. So that's a graphical representation of the sequence, and quite simply it then follows that if you wanted to graph the series values, the sum values, you'd do something similar, but you'd actually use the series formula. So it's n over 2, and it's 2a plus n minus 1 times by d, and there we have those values. And as an investigation, you could change your values for d to see how that looks, see how the values of a change that, and you've then got a representation of the first 10 terms for the sequence and as well for the series. As well as that, there's an alternative representation of the series using summation notation, which will be useful later on for the Taylor series for us, and that's for using this terminology of sum. And so we go from n equals 1, we want to sum to n terms, and basically we know therefore that this can't be m here, n, we have to make it something else. So let's say we call it m. So we want to sum each of these individual terms. So the individual terms are, it's not n, it's now m minus 1 times by d. And that's exactly the same as what we just did before. If we took that off, this will take it off, you can see that it gives exactly the same value. Alright.